So, when you think about making your application faster, your mind probably jumps to things like algorithms or maybe adding a cache, right? But what if the real performance killer, the thing that's slowing you down, is actually hiding in plain sight? Today, we're going to go deep into the persistence layer to uncover these invisible costs that can grind your application to a halt. Have you ever just stared at your screen, wondering why your database feels so sluggish, even when your queries look perfect? Well, it might be because you're paying a whole series of hidden performance taxes on every single interaction. So that's what we're going to do today. We're going to uncover these taxes and, more importantly, show you how to get a massive refund. All right, so here's our game plan for getting that refund. First, we'll talk about the high cost of just talking to the database. Then, we'll hit the connection toll booth, navigate the round-trip traffic jam, deal with a database that has amnesia, and finally, we'll solve the concurrency puzzle. Okay, first up, the high cost of conversation. Every time your app talks to your database, there's a price. The big question is, are you paying way too much? Let's find out. Okay, so here's the big idea you need to wrap your head around. Nothing is free. Every single thing you ask the database to do comes with this overhead. You can think of it like a transaction with all these hidden taxes baked in. You've got connection tolls, you've got round-trip delays, and believe me, that's just for starters. Understanding these taxes is the first step to minimizing them. So our first tax is what I like to call the connection toll booth. Actually establishing a brand new physical connection to a database is one of the single most expensive and honestly most overlooked operations in the entire persistence world. So on the left, you see the old, hard way of doing things, using a driver manager. This means for every single request, you're creating a new physical connection. It's just brutally slow and inefficient. But on the right, we've got the smart way, connection pooling. It's kind of like having a valet service for your database connections. They're all pre-warmed, sitting there, ready to go. You just ask for one and bam, you get it instantly. And this is where it gets crazy. Just look at these numbers from the source material. Opening a brand new connection takes milliseconds. Now that might not sound like a lot, but in computer time, that's an eternity. But borrowing one from a super fast pool like Hickey JCP, we're talking microseconds. That's not just a little better, that is a mind-blowing orders of magnitude improvement. So what's the big takeaway here? It's simple. You absolutely have to use connection pooling. It is the biggest tax refund you're ever going to get. It's like having an easy pass for your database. You just fly right through that expensive toll booth every single time. All right, next up is the round-trip traffic jam. So even with a super fast pulled connection, you're not out of the woods. You still have to pay a network latency tax every single time you send a statement and have to wait for the database to reply. And this slide, it just lays out the problem perfectly. Let's say you need to insert 3 rows. If you send them one by one, that's 3 separate trips across the network. Send, wait, send, wait, send, wait. It's like sending 3 separate delivery trucks when one big one would have done the job way faster. So how do we get our tax refund on rights? It's all about batching. Instead of that one-by-one nonsense, you group a bunch of statements together and fire them off in a single request. This absolutely slashes that network overhead and gives you a huge performance win. And for reads, the refund comes from something called fetch size. Just look at this chart. That first bar shows fetching 1 row at a time. It's incredibly slow because of all those network round trips. Now, look at the second bar. Bumping the fetch size up to 100 massively cuts down the time. But here's the interesting part. Notice how going up to 500 doesn't really help much more. It's all about finding that sweet spot. Our next tax is a funny one. It comes from treating your database like it has amnesia. See, every single time you send it a plain old SQL query, it has to figure out the best way to run it completely from scratch. And that is a lot of wasted work. So here's what's happening under the hood. First, the database has to parse your SQL, just to make sure it's valid. Then comes the really expensive part, optimization. The database has to look at all the possible ways to get your data, which indexes to use, how to join tables, and build the best possible execution plan. Only then can it actually go and get your data. And hey, don't just take my word for it. The author of our source material, Vlad Mihalcha, puts it perfectly. It's clear that finding a proper execution plan is resource-intensive. Making your database do that heavy lifting over and over and over again for the exact same query is just a huge waste of CPU cycles. So what's the fix? It's called statement caching. And the payoff is huge. Look at the throughput gains here. By using prepared statements that the database can cache and reuse, we're seeing massive improvements, over 55% in one case. That's huge. We're essentially giving our database a memory, so it doesn't have to keep relearning our queries. And finally, we get to the most complex tax of them all, the concurrency puzzle. This is the chaos tax. What happens when you have lots of users or lots of processes all trying to read and write the same piece of data at the exact same time? Well, if you're not careful, you get chaos. Here's a classic example, a lost update. So Alice reads a product price, and it's $10. While she's thinking, Bob comes along and updates that price to $12. Then Alice finally submits her change, setting the price to $11, based on the old data she first saw. She just completely overwrote Bob's update, and neither of them even knows it. That's a really dangerous silent form of data corruption. Or what about this one, a dirty read? Your code reads some data that another transaction is in the middle of changing but hasn't committed yet. What happens if that other transaction fails and has to roll back? Well, you've just made a business decision based on data that never officially existed. You acted on phantom data. So how in the world do we solve this? The answer is transaction isolation levels. But, and this is a big but, there's no free lunch here. This is a fundamental trade-off. You can have perfect, bulletproof data integrity, or you can have maximum speed and throughput. You can't have both. And this table, well, it just lays out that trade-off perfectly. All the way at the bottom, you have serializable. It's the absolute safest. It's like every transaction runs one after the other, no conflicts. But it's also the slowest. All the way at the top, read uncommitted is lightning fast, but you're opening yourself up to all those scary data problems we just talked about. Choosing the right level for the job is absolutely critical. Okay, let's bring it all home. Here is your performance tax refund checklist. 1, always use connection pooling. 2, batch your writes. 3, tune your read fetch size. 4, use prepared statements to leverage statement caching. And 5, make a conscious choice about the right isolation level for your needs. You know, at the end of the day, high-performance persistence isn't magic. There's no secret trick. It's really about peeling back the layers, understanding these hidden costs, these taxes, and then just systematically working to eliminate them. It's all about making that conversation between your app and your database as efficient as humanly possible. So I'll leave you with this one question to think about. Now that you know about all these hidden taxes, which one do you think you're overpaying on the most in your own application?